after the advertising campaign, the major telephone company took a random sample of 25 household bills, and he recalled the minute of 25 households their monthly usage will take the stock mean as far as 19.93. From the data, from the sample, we can see that after the campaign, the monthly, mid-monthly usage of telephone, long-distance telephone increased from 17.85 to 19.93, but it only true for 25 households we observe. So it may refer to propose the following question. Do the data allow us to infer that the campaign was successful? It may not we want to check whether after the advertising campaign, the main monthly telephone usage of all household subscribe to this company increase higher than the main monthly telephone usage before advertising campaign. Before advertising campaign, the mean is 17.85. We can summarize this example. Okay, so what is the problem? Okay, we know that before the advertising campaign, the mean telephone usage telephone usage of all household equals 17.85 dollar per month. Before. And now, after the advertising campaign, if I we compute the mean telephone usage of how many? Only 25 households equal 19.93 dollar. And so, what the question? What the research question? We can propose a research question. Whether in fact we want to test, we want to check, or we want to test whether the mean telephone usage, whether after the advertising campaign, the mean of all households. With increase, With increase means that greater than after greater than before. Increase means that after greater than before. So greater than 17.85. And you know here you want to find own household. So, here's the research question. So when the energy campaign after energy campaign the intake producing the own household will increase, it means that the campaign was successful. The campaign was successful means that the energy producing will increase. Yeah, the problem. We want to check, we want to test whether the campaign was successful. Yeah, we come back to this slide. We must answer this question. To the internal we told that the campaign was successful because here we only observe how many? 25 households. We only have information about 25 households. We don't observe all households. So we don't know whether the telephone usage of all households greater than before. Right? So we must make a decision. We must make a decision whether we accept this hypothesis. Okay, so we explain the reason after this. Now to answer this question, we need to make a decision of accepting or rejecting this hypothesis. The hypothesis with the campaign successful. So the problem now we have to make a decision of accepting or rejecting the hypothesis that the campaign was successful. It means that the mean monthly view after the advertising campaign is greater than before, greater than 17.85. Remember here Pareto we the telephone the mean telephone usage of what? Own household. Because we have it's not 19.93. 19.93 is it's S1. It's the mean of how many? Only 25. Now we have to test whether it is true for own household. If the campaign successful for 25 household, but maybe it's not true for own household. So now we have to make a decision to test this hypothesis. Here's an example. If we have another example, a very similar example. A similar example. Okay, you are given the sample. Okay, this sample consists of how many? 200 households. And in this example, we observe what? We observe the monthly electricity bill of 200 households in April 2020 in a region. And we know that in March, the mean monthly electricity bill of all households in this region is $225.5 thousand. And from the data, we compute the sample mean, we compute the mean monthly electricity bill of 200 households in April is 236.78. And we can see that this value is greater than 235.5. So we propose a research question whether the mean monthly electricity bill of all households in this region in April is greater than in March. Whether the mean monthly electricity bill of all households in this region. So we can model. This model has draw the graph, the histogram of the data. Here the histogram, the distribution of electricity bill of how many? Of 200 households. And we can see that the shape of the histogram is nearly similar to a bell. And so, because the shape of the distribution of data is similar to a bell, so we can suppose that we can model the variable x is a monthly electricity bill of all households in the follow a normal distribution with the parameter v and variance r square. So what is the v? V is the known or unknown? We don't know V because we don't observe the own household in April. We only observe the 200 household. So V, what is the V? Parameter V? V is the population mean. That's the mean monthly electricity bill of all households existing in April. And V is what is unknown, sigma is unknown. We focus on parameter V. So from the data, we compute the sample mean is 236.28 and greater than 235.5 is a mean in March. So we state the following question. Here's the research question. The research question. There is enough evidence to infer that the mean monthly electricity bill of all households in April is greater than that in March. Here's the research question. So go here's the research order. This hypothesis is only true for the sample. And what is the evidence? Yeah, here's the evidence. The evidence is the sample, is the data. Okay, so what is the problem of testing? What is the problem of testing? Here's the problem of testing. So we can so what is the goal in this sample? The goal we must to make a decision. We make a decision to accept or reject the research hypothesis. And the decision depends on what? Based on what? So decision based on the data. The data of the sample. In fact, the data and the sample is called the and the evidence. The evidence is the data. And remember, in fact, the data or the sample, in fact, or the evidence always support for the research hypothesis. For example, we have we have x bar is 236.28 greater than 200 greater than 275.5. As the sample, the data on the way support the research hypothesis. Before okay, now we define what is the testing hypothesis. So testing hypothesis is a what? What is the goal of the testing hypothesis?
Support
Testing the hypothesis is to
measure the data.
Make a decision of accepting or rejecting the hypothesis based on what? Based on the sample, the data. Okay. There's the definition of testing. So in this chapter, we study about hypothesis testing. You are given data sample, and we state a hypothesis, and you have to make a decision to accept or to reject the hypothesis. The conclusion, we accept or we reject the hypothesis. Okay, now we study the procedure to construct the decision rule. How to construct the decision rule to accept or reject the hypothesis? So we compare the slide. Of course, we will introduce some definition first. Okay, firstly we introduce some important. We come back this example. What is the result hypothesis now? The hypothesis the mu greater than 225.5. Yeah, mu what is mu? With the population mean, the mean homogeneity view of all household. So we must to make a decision to accept or to reject this hypothesis. We accept mu greater than 225, so we conclude that the homogeneity view in April greater than in March. If we do not accept, we conclude that the mean homogeneity view in April is not greater than in March. We answer this question. Okay, so to answer this question, we follow the following procedure. The first step, we have some definition. The first definition, the result hypothesis of the result hypothesis is the hypothesis to be tested. Right? So in this example, the result hypothesis is to be greater than 225. Okay, so and we need to accept or reject this hypothesis. This called the result hypothesis. Okay, now so what is the logic here? To effectively the data on the way support the result hypothesis, right? So to accept the hypothesis, we will find the evidence to reject the opposite hypothesis. It means that to prove I am true, I don't prove I am true. I prove
The result is true.
to prove I am true. I will prove
The result.
you are wrong. But to prove I am true, I will prove you are wrong. So we will construct the second hypothesis is called the non-hypothesis. We state an opposite hypothesis with the result hypothesis, and this hypothesis is called the non-hypothesis. Labeled by X naught. Okay, so the result hypothesis mu greater than 225.5. So what is the opposite? Hypothesis with mu greater than 225.5. Is the mu smaller than or equal. If I to accept the result hypothesis, we will reject the opposite hypothesis. We reject X naught. We will find, we check whether the data or the evidence is strong enough to reject X naught, to accept X naught. Now, to make the decision of accepting the result hypothesis, we test whether the information of the sample is strong enough to reject the null hypothesis. It's not. The idea is similar to prove I am true. I will prove you are wrong. I don't prove I am true. I prove you are wrong. So, you are wrong means that if you reject it's not, we accept the result of the test. And the next definition, the result hypothesis is called the alternative hypothesis labeled by S1. So we have two hypotheses, S0 and S1. What is S0 and what is S1? S1 is usually the result hypothesis. S1 comes from the data. And it's called the alternative hypothesis. We also label S1 by SA. S1 or SA. Okay. So the first step to make the first step to do a test, you construct a couple of hypotheses, S0 and S1. And the problem of testing, we must make a decision to accept S0 or to accept S1. Because we take the null hypothesis against the alternative hypothesis. Yes, the null hypothesis. Yes. Alternative hypothesis. Okay. And when you make a decision to accept or reject S0 and reject or accept SA, there are four outcomes. There are four outcomes of testing. It's similar to four outcomes when you, in fact, when you make a test of COVID 19 virus 19 COVID or the SIV virus, you have four outcomes. What are four outcomes? False positive, true positive, false negative, and true negative. So in fact, the test of SIV virus is a test of hypothesis. Here are four outcomes, and out of these four outcomes, there are two correct decisions and two incorrect decisions. So what are they? But this table is important. You must remember the four outcomes. For the decision, there are two decisions. You accept S0, so we reject S1. And you reject S0, we accept S1. And the fact, there are two facts. S0 is true. So S1 is false. And the second fact, S0 is false, so S1 is true. Okay, the first outcome, you accept S0 when S0 is true. But we reject SA when SA is false. So this is the correct or incorrect decision? Correct decision. Because you accept S0 and S0 is true. So it's correct decision. The second, you reject S0 when S0 is true. It is a incorrect decision because S0 is true, but you reject. So it's the incorrect decision. Or you accept SA when SA is false. The third outcome, the third decision, we accept S0 when S0 is false, or we reject SA when SA is true. Yes, the incorrect decision. And the last one, you reject S0 when S0 is false, and you accept SA and SA is true. Right? There are three outcomes. And for the three outcomes, we focus for the four outcomes, we focus on three outcomes. The first is the Taiwan error. The second outcome is the Taiwan error. We have Taiwan error if we reject S0 when S0 is true. The second error, type 2 error, we accept S0 and stays important. The correct decision, important correct decision. We reject S naught when S naught is false. Why? Why this outcome is important? What is the last outcome? We reject S naught when S naught is false. If we accept when we accept S1 when S1 is true. Why? Why this outcome is important? What is S1? S1 is the research hypothesis. We accept the research hypothesis, and the research hypothesis is true. So it's important. Tôi nói là tôi đúng và thực sự là tôi đúng. Okay. We now we summarize these four this example Taiwan error. Taiwan error, we reject it not when it is true. But we infer that. We reject it not, so we infer that we greater than 225. We state that, we conclude that the mean Martini telephone bill in April greater than in March, but it is false. It's not true. The second error. We accept it's not when it is false. But we reject S8. We accept it's not, so we state that we smaller than 225, but we really greater than 225. There are two types. And then we define the probability of three outcomes. Probability Taiwan error is 1 alpha, probability Taiwan error is beta, and the power of test. The power of test is last outcome is 1 minus beta. This probability is that we accept S1 when S1 is true. And when you make a decision, of course, we on the way with that, the probability of error is as small as possible. Okay? For example, you are going to a boyfriend. You on the way with that, you choose you on the way with that, you make a true decision. Or the probability, the chance you make a wrong decision is small as possible. Right? So when you make a decision with the beta and alpha and beta is as small as possible as together. But it is impossible. Why? Because alpha and beta cannot be small together. Alpha and beta cannot be small together. Because when alpha decrease, when alpha is small, beta will increase. And inverse, when beta decrease, alpha increase. Beta, alpha and beta cannot be small together. So how to do? Nhưng mà lại chọn người yêu và để đặt ra hai tiêu chí là gì? Càng giàu càng tốt và càng ngoan càng tốt, đúng không? Nhưng mà hai tiêu chí đấy thì nó thế nào? Nó không đồng thời xảy ra được. Okay. Bởi vì sao? Những cái anh mà càng giàu thì sẽ càng hư, và những anh càng ngoan thì càng nghèo. Tức là giả sử thế, đúng không? Thực tế có thể không thế. Thì giàu thì đo bằng số biệt thức ở Tây Hồ, đúng không? Ngoan thì đo bằng số lần lên 3 một tuần, đúng không? Tức là các anh càng giàu thì lên 3 càng nhiều, đúng không? Còn ngược lại, anh càng ít lên 3 thì càng nghèo, tức là càng ngoan, đúng không? Càng nghèo. Cái bạn này bạn phải đặt ra hai tiêu chí đấy có thể đồng thời được, người ta làm thế nào? Ta phải chọn ra một tiêu chí, đúng không? Đấy, bạn này đánh giá cao là thực dụng, bạn chọn cái này giàu rồi. Thì trong số những anh đủ giàu, bạn ấy sẽ chọn làm sao? Chọn anh ngoan nhất, đúng không? Tức là trong số những anh có từ 3 biệt thự trở lên thì ta sẽ chọn ra cái anh nên 3 ít nhất, đúng không? generally. Okay, now alpha and beta cannot be small together. So how to do? We must control one type, one error, and we find the decision rule such that the other error is smallest as possible. Right? So now, which error we control? We control type 1 error or we control type 2 error? We control type 1 error or we control type 2 error? Okay, we will control the more dangerous error. Right? Which the error is more dangerous, we will control. Right? So the type 1 error or type 2 error is more dangerous.
Type 2.
Type 2 or type 1 is more dangerous. 1 or 2?
2.
1 or 2?
2.
1 or 2 is more dangerous. 1 or 2? 1 or 2? 2. You choose 2. So the answer is
2.
is 1. Còn Tào Tháo is 2. Why? Tào Tháo nói rằng cứ muốn làm việc lớn bên nhà hỏi vợ, vợ bảo sao làm ngược lại anh sẽ thành công. Bây giờ áp cho sinh viên thì làm gì? Muốn biết đáp án câu hỏi sinh viên trả lời thế nào? Chọn ngược lại. Đúng không? Nhiều các anh sẽ đúng. Biết phải nào biết tên của hai ta quan hệ giờ đi trước. What type of error? Type of error, the reason is not when it's not is true. Type 2 error, reason is not when it's not is true. If we accept S1 when S1 is false, right? Type 1 error. Type 2 error. Accept S not, so we reject S1. S not is false, so S1 is true. Okay, we write here. Type 1 error. And this way is why. What are Taiwan error? It's very important for this definition. One key with how to remember reason is not. You only remember this place. To remember the other outcome. You only remember this place, Taiwan error. Reason is not. Right? And then, of course, it's not in 4 or 2. 4 or 2. Of course, it's 2. And 2 is the error. Okay? So, we accept SA when SA is false. And then what type of error? Well, now we reject it's not, we accept it's not, reject it's not is type 1, so accept it's not is a type 2. When it's not is a false. So the probability such that we reject SA when SA is a okay, now I ask you. Why type 1 error is more dangerous? Okay, now problem. We just alpha and beta. Yeah, alpha. Yeah, beta. Are small together. But what? But it is impossible. Why? Why? Because if alpha decrease, then beta increase. And if beta decrease, then alpha increase. We control. We control one letter. We control Taiwan letter. Why? We control Taiwan letter. Why we control Taiwan letter? The reason because Taiwan letter is more dangerous. Taiwan letter is more dangerous. You can look at here. What the Taiwan letter? Accept when it is full. What does it mean? It means that I am true. But in fact, I am false. Okay? And then what type of letter? We say essay when essay is true. Okay, I am wrong. But in fact I am true. Cái thằng thứ nhất thì là cái thằng nào? Cái thằng I'm true, but I'm wrong. Thằng thứ hai, okay, I am wrong. But in fact I am true. Thằng thứ nhất là thằng nào?
Dạ đúng đấy.
Thằng đến bảo bạn này ơi em ơi, nhà anh ấy có 3 cái biệt thự ở Hồ Tây, 4 cái biệt thự ở Vinhome Riverside, nhà đầy siêu xe, nhưng thực ra là đi thuê nhà ở. Đấy là anh gì nhỉ? Anh Ba Hoa Buffett. Cái thằng Ba Hoa Buffett là cái thằng như nào nhỉ? Sai này nè, nhưng cứ loa đi là đúng không? Còn thằng thứ hai là thằng gì? Thằng khiêm tốn là gì? Nó đúng thì nó không nhận được đúng không? Nhớ ra SA là cái sơ học thì gì? Anh khiêm tốn là anh đến là gì? Anh bị thưởng thôi đúng không? Anh vẫn đi xe máy cà tàng, anh đi thuê nhà, thực ra là nhà 3 cái biệt thự ở Vinhome đúng không? Đấy, thì rõ ràng là trong hai cái nhóm đấy thì bạn này bạn phải kiểm soát cái nhóm nào nhỉ? Phải hạn chế cái nhóm nào nhỉ?
Nhóm Hồ Tây.
Hạn chế cái nhóm Ba Hoa Buffett gì nữa đúng không? The reason we control Taiwan error is Taiwan is more dangerous from a system is okay? Okay, we are to find this the default interface. Okay, we will control Taiwan error at a given level induced by alpha, and this level is called the level of significance, and the test is called the test of significance. It's an important definition. In the final exam, we can ask you this question: what is the level of significance? Or explain the meaning of level of significance. We usually choose alpha is 1%, 5% or 10%. We choose alpha is small. We choose alpha 1%, 5%, or 10%. Okay, we consider alpha is 1%. What does it mean? It means that we control the probability of Taiwan error at level 1%. It means the probability of Taiwan error smaller than or equal 1%. Nghĩa là bạn này bạn đi kiểm soát là gì nhỉ? Trong số 100 anh đến thì số anh làm sao nhỉ? Ba Hoa Buffett thì nhiều nhất là 5% thôi. Okay. Okay, so we have an important definition. You should remember the definition